Okay, so today we're going to be talking about social neuroscience and neuroscience of emotion. So, how our brain operates and interacts with people in groups, how we feel feelings, things like that. And one thing I should mention from the get go is that these two branches of neuroscience, specifically social neuroscience, so social neuroscience in particular, is an extremely young field. And when I say that, I mean an extremely young field. Like the term social neuroscience didn't really exist before your lifetime. And, most of you are only probably in your early 20s, late teens. So there's a lot less cohesion and understanding than other domains of cognition. When we talked about vision, we were able to go, from the eye to the LGN to V1 to the two pathways. We really could go through that in depth. And that's because people have been studying those systems for years and years and years. This is really just getting going with something like social neuroscience and emotional neuroscience. So we don't have nearly as much cohesion, which makes some sense because when you think about it, we're trying to study something very complicated. We're trying to study the neural correlates of complex thinking about very personal thoughts, very personal feelings, emotions, and so on and so forth. So rather than us being able to talk about any sort of like grand frameworks of social cognition and social neuroscience, we're going to talk about in our three different modules or three different little sections, three aspects of social cognition and how we study them neuroscientifically. So they are social influence, peer pressure, and conformity, how we perceive and judge social groups that are like us or that are different from us, and then how we go about understanding other minds and other individuals. Okay, so let's start with social influence. And like I said, there's going to be a particular focus on the domain of conformity, because as I'm sure you all can, comprehend if you just think about it for a given second, we conform to social norms to function successfully in society all the time. We have an understanding of the proper etiquette. We have an understanding of the kind of things you'd wear to a job interview. We have an understanding of how much eye contact is enough eye contact, how much eye contact is too much or too little, and so on and so forth. When you see someone during a thing that's, during a period that's not the pandemic, you have an understanding of like social distance that you maintain, which has obviously changed. Actually, you know what? We even have an etiquette and understanding of what appropriate social distance is now during quarantine and so on and so forth. So these are just a bunch of small examples of social norms, but of course there's much larger ones. And it turns out that for several years, neuroscientists have known that damage to certain parts of the brain does lead to aberrant, unsocial behavior. So way back at the beginning of the course, I think in the second week, we talked about how with Phineas Gage, once he damaged his frontal lobe, some people said that he became violent, uncontrollable, he molested children, and that those close to him said he was no longer Gage. People who experience frontotemporal dementia, which is a particular type of dementia that goes after the frontal cortex in particular, which we'll talk about actually the very last week of the course, in about 2 weeks from now. These people, as they get older, their behavior becomes much more erratic and much more outside of the social norms. And similarly, in general, there's been a ton of work that has been done more recently with patients who have orbitofrontal damage who don't really necessarily understand that they're not acting appropriately. And so there's a lot of famous patients like this where they do this task where they will basically ask the patient to kind of playfully tease a member of a scientific group. So, give him a hard time about his shoes or give him a hard time about his, tie or something still, kind of playful teasing, like good-natured ribbing. And they just get way too personal, way too fast. Like they just go way over the line and they cross the line way too much. Similarly, when you ask them to share some information about themselves, they will maybe completely overshare. They'll do a little bit of TMI type of thing. And so they might necessarily understand like, oh, you're not supposed to be too mean. They might understand, oh, you're not supposed to overshare. But then in the moment when they do it, they don't realize that they've done it. So there's a lot of cases of how our brain, in particular our frontal lobe, how when it is damaged, seems to make it harder for us to conform to these kind of social norms of society. Okay, but let's get away from talking about it in neuropsychological cases. And let's talk about conformity on a much smaller scale that we can do experimentally in healthy individuals. And probably the most famous study about conformity are the Solomon-Asch conformity studies. So just as a reminder, you all probably learned about this in intro psych. In this study, you as a participant would come in and you'd be told, okay, this is the target line here on the X, match this line over here that we've designated with an X, match it with either the line A, B, or C. Which one does it match to? And in this case, hopefully you can all tell, it would be line C that you would say is the correct answer. And the way that this experiment works is that you would come in and there'd actually be several other people who are a part of the experiment, but in reality, they're stooges, they're confederates, they're part of the experiment. So you come in, you're the participant, all these other people who you think are also participants, they're actually part of the experimental team working with Solomon Asch. And they're going to kind of play a trick on you, because in a situation like this, for example, in this case, even though the answer looks like it's B, they are purposely all going to give the wrong answer. They're going to say A, or C, 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 C. And so you are in this situation where you're going fourth, fifth, last, whatever. And sometimes there's pressure to conform because everyone's saying an answer you don't want to say. They're saying the wrong answer. But sometimes there is no pressure to conform because they're giving the answer that you want to give. And so what you could do is you can plot how accurate people are at picking out the right line of those three options. And you can look at how well they do across several trials when there's no pressure to conform, whereas when the Confederates or the Stooges say what you would want to say, or when there's pressure to conform in that situation where they give the wrong answer. In that case, the data looks like this. When everyone says what you want to say, you get it right pretty much every time. But when everyone says something different, you're very likely to be like, wait, something's not right. I must not understand it. I don't want to be the odd one out. And so I'm going to conform and do what other people are saying. Okay, so this is a very, very classic study from like, 60s, 70s, something far back like that. All right, so then the question is, though, how could you adapt this for a neuroscience experiment? It's kind of tricky because you can't get multiple people lined up and, fMRI side by side. So they had kind of a clever idea. So what they would do is they would put you in the scanner and they would show you a face for 2 seconds, male faces, female faces, different ages, races, ethnicities, so on and so forth. And then they would ask you on a scale from 1 to 8, just rate how attractive you find that particular face. And so in this particular case, whoever the participant was saw this face here and rated that as 6. So the blue is a 6, okay? So leaning more towards the attractive side than the unattractive side. And then as soon as this person gives their response, what they're told is, okay, well, this is what the average group rating was, okay? And so the red box is saying that on average, when we asked a bunch of other people, that group would say, oh, this person actually wasn't a 6, this was an 8, okay? And then there's a little interstimulus interval and you go on to the next trial. And so then what they can do is that they can then later ask you a second time to give another rating, okay? So they're gonna show you the same face again. They're gonna ask you to just do another rating. It's like, outside the scanner, just, get a really good sense of it. Can you give us another estimate? And what they found is that people, much like in the Asch studies, their answers would be biased. So if before this person said a 6, since the group average was an 8, they're like, you know what, on second thought, I'm actually gonna change it to a 7, okay? So this is just a small little example where you can see some peer pressure playing a role in what people would say. And so what you can do is you can look at people's performance on that second trial here on the vertical axis, and going up means that they're going to start rating the people the second time as more attractive, and going down means that the second time you see those people, you're gonna say they're less attractive. And you have 3 conditions. You have it when the group said that the face is more negative than you did, the group said the same thing as you, or the group said it was more positive than you did. And what would you expect to happen is something that looks just quite like this, where if you and the group agreed from the get-go, you don't really change your answers. If the group says that the face was more negative than you did the first time, the second time you're like, oh yeah, on second thought, okay, yeah, that face isn't as attractive. Or if the group is like, yeah, that person actually was, was really very attractive, then the second time you're like, yeah, they were really very attractive. Okay, so this is just showing that behavioral influence. So while they were doing stuff like this, they would look at different parts of the brain to see what would happen. And 2 parts of the brain really kind of stood out. There's this one part in the frontal lobe called the rostral cingulate. And this is an area that has been shown to become active when you're trying to make a decision in the face of conflict, when you're kind of experiencing tension, you're not sure what to do. And in this case, the conflict is coming from the fact that you're giving an answer that's different from what the other people in the group supposedly said, okay? In addition, there's an area called the nucleus accumbens, which is a reward region of the brain. This is actually a general part of the brain that gets really active when anything kind of pleasurable is experienced. If you get social affirmation, if you eat a really good candy bar, if you hear your favorite song, the nucleus accumbens is kind of an area that the more it's active, the more pleasure and reward you're feeling. So what we can do is we can look at how these 2 different brain areas, the rostral cingulate and the nucleus accumbens, activate when you give a rating of the person's attractiveness that is either in conflict with the group or when there's no conflict whatsoever. So these 2 things here on the left are when you and the group give a different answer, and then over here on the right, you and the group give the same answer, okay? What would you think is going to happen in these 2 different regions? You're actually gonna see opposite effects, okay? Because they look like this. And if in the rostral cingulate cortex, what you see is that when you and the group disagree, it's far more active than when you and the group don't disagree. Because again, this is an area that's involved in, you're trying to kind of balance all these decision-making processes, and you're in the face of conflict. Whereas the nucleus accumbens, it gives you the exact opposite region or pattern of activity in this region, because when you're not in conflict with the group, you're like, yay, okay, cool, I fit in, I belong, there's agreement, this is a good thing, this is a good day. And so you can see now how these different sorts of brain areas will activate in different patterns as a function of whether or not you have successfully fit into the group or not. So then these researchers had this natural question of asking, well, what happens if you disrupt this region with TMS, okay? What do you think is going to happen? Now, the reason that they asked it about the rostral cingulate as opposed to the nucleus accumbens is if you look at the nucleus accumbens, and where this little region is, it's deep in the brain. Like you'd have to drill in from multiple settings. You can't really get all the way into that part of the cortex. So the nucleus accumbens, because of the limitations of TMS, is just not a region that you're gonna be able to actually reach. The rostral cingulate, it's close enough to the surface that you have some hope that maybe you can potentially reach it. So they're gonna focus on that one to see what's gonna happen in this particular task with group ratings of attractiveness as you TMS, okay? And so what we're going to do here is we're going to look at how people's behavior changes. Okay, so these behavioral adjustments that we're talking about here on the vertical axis are the exact same ones that we were looking at a second ago when we were talking about how you're going to second time make a face. You're going to say the second time that a face is either more attractive or less attractive. Same exact paradigm, same exact situation. And that's what we're now doing on the vertical axis here. And so there's 3 TMS control conditions. There's a control TMS, which is this part in the back of the head that is, part of the brain, obviously, but it has nothing to do with this circuit that we're talking about. A sham TMS situation, which we've talked about before as well, where you set everything up, you tell them you're going to zap them, but then at the last second you don't. And then here, this one where you actually do what they call prefrontal medial frontal cortex, which is in this case where the rostral cingulate is, okay? So now we have 2 situations when the group rating is more positive overall and when the group rating is more negative overall, okay? And when the group rating is more positive overall, okay, then the second time what you're usually going to do is you're also going to change your answers above this baseline to say, yeah, actually, now that I think about it, that face was really attractive. I take it back. I gave him a 6. I should make them like a 7 or an 8, okay? When you don't TMS people on a sham or you TMS them in a control condition, you can see that people will change their answer to conform to the group even more than if you TMS this prefrontal cortex region, this rostral cingulate region, okay? So this little white box is below the black and the gray box, and that difference that you're seeing between them, that's showing how you're less likely to conform to the behaviors of the rest of the group when this part of your brain is being turned off while you're making this decision, okay? What are we expecting is going to happen over here when the group rating is more negative? A pretty similar effect in the sense that, yeah, when you don't TMS them or you TMS a control region, you see a big change from baseline. They're like, oh yeah, you know what, you're right, that person isn't that attractive now that I've had some time to think about it. But again, when you TMS the rostral cingulate region, you're not as biased by the group as you were when that part of the region, the brain is working and firing on all cylinders. So this is just kind of a small case example where you can see how if you change someone's brain, you can actually change the way that they conform. You can actually change their behavior. And in a sense, if you look back at this data, what these 2 white boxes are saying is like, as you get closer to baseline, it's almost like, oh, I don't really care what the group says. I care about what I want to do. I care about what I think. I'm not as biased by what the group says, okay? I'm not as likely to kind of conform to what they're trying to do, conform to what they're trying to tell me. It starts to make some sense like, oh, this is why a person like Phineas Gage kind of loses interest in social norms, or why people with frontal temporal dementia kind of don't adhere to these social norms, because in the same way, for this brain region, if it gets changed, it will also change the way that a person will conform. And so you can actually see then with a study like this, how people and neuroscientists in particular are going to study social influence. And this is the kind of foundational approach that people do, is taking these sort of social experiments and trying to put them in a neuroscientific setting to see how your views of social situations, social conditions, social opportunities vary as a function of what's going on in your brain. So that's one example of social neuroscience. Let's now move on to the next one, which is talking about not just how you're influenced by a social group, but how you actually yourself will perceive and even make judgments about a social group that's either a group like you or a group that's not like you, sort of an in-group, out-group thing. But why don't we take a little bit of a break, and when we come back, that's what we will do with the next module or the next lecture.